So, average velocity, which is also equal to displacement over time, v plus u over 2 will be equal to displacement x also over t. X will be equal to this t will multiply what is here, v plus u over 2 multiplied by t. So from this equation, you can see that S will also be equal to V. And we know that V from equation 1, V is equal to U plus AT. So we shall put U plus AT there. U plus AT. V, which is U plus AT plus U all over 2 multiplying T. And this will also be equal to U plus U will be 2U, and this T will multiply 2U, so we have 2UT plus AT will multiply T, then we have AT squared. All are divided by 2, so here divided by 2, here also divided by 2. You can see that S will be equal to these 2 will go. You have UT plus, this can be written as half AT squared. And this is second equation of motion. Second equation of linear motion. Again, from S is equal to V plus U over 2 multiplying T. S, which is said to be equal to V plus U over 2 multiplying T. And from the equation of acceleration, A is equal to V minus U over T. If we make T the subject, so we can say T is also equal to V minus U over A. That is from definition of acceleration. And then T is equal to this, and we put it what is here. We can write X will be equal to V plus U over 2 multiplying T, and T is also V minus U over A. When we simplify this equation, you can see X will be equal to multiplication of fraction. You multiply the numerators. When you multiply the numerators, we have V plus U, V minus U. All over 2 multiplying A, we have 2A. That is multiplication of fractions. You multiply the numerators, you multiply the denominators too. Alright, S will be equal to this, and then this becomes difference of 2 squares. So we have V squared minus U squared over 2A. 2A. And this 2A will multiply S, so we have 2AS will be equal to V squared minus U squared. And if we make V squared the subject from this point, then we can say V squared will be equal to U squared plus 2AS. And this is third equation of linear motion. Third equation of linear motion. Now, let me summarize these equations here. So we can say that summary one, for the first equation of linear motion, V will be equal to U plus AT. And the second equation of linear motion, S is also equal to UT plus half AT squared. And then 3, we also have V squared, which is equal to U squared plus 2AS. And we also need this one, S is equal to V plus U over 2 multiplying T. And you should notice that V is always final velocity, U is initial velocity, A is acceleration, T is time. S represents displacement or distance in a specified direction. That is for S. Displacement or distance in a specified direction. So these are the equations of linear motion. And the next will be how to use this equation to solve questions. And all depends on the question given to you. So if you provide your data for the particular question, sometimes you'll be given final velocity, initial velocity, and then the time, and then you'll be asked to find acceleration. And you should know the type of equation you should use to solve for the unknown variable you have been asked to solve for. At times you will need one of the equations to solve one of the unknowns, then you can use another one to solve what you have asked to solve for. And we shall look at that one later. And these equations are motion on a straight line. Motion on a straight line. Let's talk about motion under gravity. Motion under gravity. Before we use them to solve questions in our next meeting, let's quickly discuss motion under gravity. Let me clean this side. Motion under gravity. That is vertical motion under gravity. Let me bring vertical motion here. Vertical motion under gravity. Okay. So here, under motion under gravity, we have upward motion, we have downward motion. If I write here, upward motion. Under gravity, upward motion. Then downward motion. Under gravity. For example, when a stone or an object is thrown upwards, vertical, then it becomes upward motion. And when it is coming down, it becomes downward motion. For example, when when an orange falls from the tree to the ground, it undergoes downward motion. And when we throw a ball upwards, so that we have upward motion. And for that matter, the first equation of motion will become V will be equal to GT, where the G is the acceleration due to gravity, motion under gravity. It means when you throw an object upwards, the acceleration decreases. The acceleration decreases. And for that matter, we call the negative acceleration retardation. Retardation. Or what we call deceleration. That is negative acceleration. Deceleration or retardation. That is when you throw an object upwards, it begins to decrease in motion because of negative acceleration. It will reach a point where it will stop before it comes down. So when it is coming down, the same equation 1 for downward motion will be V will be equal to U plus GT. This means when it is coming down, the acceleration will keep on increasing. That is positive acceleration. The equation 2 for upward motion also will be X will be equal to UT minus half GT squared. Okay, for acceleration for upward, which is negative, and for downward, S will be equal to UT plus half gt squared. Then the third one, which also involves acceleration, v squared will be equal to u squared plus 2gs. Sorry, here will become minus 2gs. Minus 2gs. Same thing here. 3 v squared will be equal to u squared. Here will be plus 2gs. That is for motion under gravity. Motion under gravity. Motion under gravity. You have both upward and then downward. So you have to learn these equations, and I've explained to you why they are plus for downward and why they are minus for upward. I want us to end here, and in our next meeting we shall use these equations to solve questions. So before I end this video, let's solve one question so that you go and look at the other questions in the notes I've attached online. Example. So let's solve this question. Determine the distance covered by a body in 4 seconds. So you provide your data. Time is equal to 4.0 seconds. If its initial velocity is, that is u, is equal to 20 meters per second, and the acceleration a is also given as 4.0 meters per second squared. This is motion along a straight line, not motion under gravity. So if it's motion under gravity, the acceleration will be specified for that. And if you are provided with this data, you can see that equation 2, s is equal to ut plus half at squared, can be used to solve this question. So all what you do is you substitute in your values. U, which is 20, t, which is 4.0, plus half a is 4.0, multiplied by t squared, and t is 4.0 squared. And when you compute this multiplied by that, we have 80 plus this will be 2 multiplied by 16 squared, which is 32. This one will be 112 meters. That is x equal to 112 meters. After solving this question, and I've attached a lot of questions in the note I have given to you online. And you can meet me online at ikebuanti@yahoo.com, or you can call my number 020-8717-604. On Tuesday, 4 o'clock p.m. to 6 o'clock p.m. You can meet me directly online during this time. And whatever problem that you encounter, you contact me there and we will solve it together. So students, ensure that you read your notes on the platform I've informed you, and also read all the assignments. Make sure you go through it